and solve some questions. All right, so let's say here, guys, so in this one, all right, now when you take a look at this, we can immediately see that we have a semicircle right here where nm is the diameter. Now keep in mind, guys, that the angle that is not at the vertex of the diameter in this case, which will be I, now that angle will always be a right angle. So in this case, we can immediately see that our angle x is equal to 90 degrees. All right, so our angle x is 90 degrees. Therefore, using the sum of triangle property, we can immediately know that our angle y will be equal to 50 degrees. All right, 180 minus 90 minus 40. All right, guys. Now let's go ahead and solve some question. Again, we see that if you take a look at it, guys, so here is the diameter. So let me say this is A, this is B, right? Let me say this is A, this is B. So the angle that in from the semicircle, which is not at the vertex of the diameter, an easy way to remember is the right angle. So in this case, guys, our x will be immediately 90 degrees, right? Our x will be immediately 90 degrees. Therefore, our angle y using the sum of triangle property will be equal to 30 degrees. All right, 180 minus 60 minus 90. Now these are very easy questions. Now let's go ahead and name the diagram. All right, the central angle subtended by arc CB. So subtended by arc CB means it should start at C and end with B, which is right here, right, guys? So if we take a look at this, it will be COB, right? It will be C going to the center and coming back to B, COB, right? COB. Now, if they say the arc BC, then it would be BOC, all right, guys? The next one, the central angle and inscribed angle by arc AD. All right, so we have arc AD. So our central angle will start from A, go to the center and come back to D. All right, guys, so what angle will that be? What angle will that be, guys? It will be angle AOD, right? And the inscribed angle will start at D, touch a part of the circle, which is C right here, and comes back to D. So in this case will be ACD. All right, guys, will be ACD. Now what do we have here? Now the inscribed angle subtended by a semicircle. Ooh, what I want to do is click the pause button. All right, try and think by yourself and come back and check the right answer. So subtended by the semicircle, guys, by the semicircle will be DAC, right? Will be DAC. And the right angle in this case, the right angle, right? The right angle will also be DAC, right? So in this case, this is our diameter, right? This is our diameter. So subtended by a semicircle, right? And we're talking about the inscribed angle. So it should start with D, touch a part of the circle, in this case is A, and go back to C, right? And go back to C. And of course, this angle right here will be our right angle. As you can see, the angle or the vertex that is not the diameter, so in this case the diameter is D and C, right? So the angle that is not a part of the diameter will be the right angle. And in a triangle there are 3 vertices, so we have got rid of 2, that means you only have 1 left. So in this case, the right angle will be DAC, or you can also name it as CAD, all right? Whichever way is correct. Question 2. Name a central angle and inscribed angle subtended by the same arc. Shade the arc. All right, so let's go ahead and shade the arc. All right, let's go ahead and shade the arc, which is right here. So this one will be our arc. Now the central angle will of course start from here, touch the center and come back to here, and it can be vice versa, right? So the central angle will be BOA, or it can also be AOB. And the inscribed angle will start at the same arc, go and touch the circumference and come back to the other arc subtended by this arc, right? So in this case it will be BCA, or it can also be ACB. All right, it can also be ACB. All right, now this is a nice one. Let's see if you guys can name the central angle and the inscribed angle subtended by the arc QR. All right, hit on the pause button, try to write it down and see if you got the right answer. All right, now let's check if you guys got the right answer. All right, so for a central angle, guys, so it starts at Q, So it should touch the center, which is right here, and end at R. All right. And it can also be vice versa. So you can either name it as QOR or it can be ROQ. All right. Now for the inscribed angle, again, it should start at Q. It should touch a point of the circle and come back to R. All right. So in this case, will be QPR or RPQ. All right, guys, QPR or RPQ. Question number 3. All right, in this case, guys, we see that both these angles are subtended by the arc GF, right? So we have GOF and then we have angle GHF, right? GHF. Now this is the central and this is the inscribed, right? And we know that the central angle is twice the inscribed angle, right? Central angle is twice the inscribed angle. Therefore, it will be 2 times 28 degrees, which is equal to 56 degrees. Alrighty, let's go to the next one. In this case, now what many students think for the inscribed angle part is, it should always look something like this. All right, it should always look something like this or something like this. Now, if you take a look at this, now we see that this angle TOR is the central angle and angle TSR is the inscribed angle. All right, guys, it does not always have to go up. All right, now we see that the central angle is 84 degrees, right? And we know that the inscribed angle will be half of the central angle, in this case, half of 84 will be 42 degrees. All right, guys, so when you see these kind of questions, don't always get confused that the inscribed angle should always go up or whatnot. It can also go sideways. All right, guys, we just follow the theories, right? And you all should be good to go. Now in this case, guys, we can say that we have the arc DG, right? And these are the inscribed angle. We have angle DEG and then we have angle DFG. It starts at D, touches a part of the circle, comes to G, and here it starts at D, touches a part of the circle and comes to G. So it is a fair statement to say that both of these are inscribed angles, right? And we know that the measure of the inscribed angles will be equal. Therefore, our angle X will be equal to 72 degrees. All right, guys, angle X will be 72 degrees. Now let's see what we have here. Now here we'll be using the semicircle property, right? We know that KJ is the diameter and X will immediately be 90 degrees, right? Pretty straightforward. X will immediately be 90 degrees. Now here, guys, if you take a look at it, if I say this is A and this is B, this point A and point B, so this is the arc AB, right? This is the arc AB. Now we see that all of these are the inscribed angles, right? It is starting at B, touching a part of the circle, right? Starting at B, touching a part of the circle and going to A. It's starting at B, touching a part of the circle and going to A. Starting at B, touching a part of the circle and going to A. So it is a fair statement to say that all of these angles are inscribed angles, right? Therefore, the measure of inscribed angles will be equal. Guys. Now here we go. All right, so let's say I name this point AB again, this point AB. We know that this angle and this angle are the inscribed angle, right? We know, so therefore our angle Y will be immediately equal to 15 degrees and our angle X will be the central angle, which will be twice as the inscribed angle, which will be 30 degrees. All right, guys, which will be 30 degrees. All right, here we go, guys. Now in this case, so what we have, we got to do it step by step. All right, we got to do it step by step. Now we see that OA is equal to OC, right? OA is equal to OC because both of them are the radii, right? And these two angles will be equal. So we know that this angle is equal to 25 degrees, right? We know this angle is equal to 25 degrees. Now using the sum of angles in a triangle property, we know that Y plus 25 plus 25 is equal to 180, right? Therefore, Y is equal to 180 minus 50. Therefore, Y is equal to 130 degrees, right? Y, therefore, will be equal to 130 degrees. All right, y will be equal to 130 degrees. Now, knowing that, we can immediately find x, which is equal to half of the central angle, which is equal to 65. Or guys, you can also do the method that I just showed here, which is using the angle sum property. So this angle plus this angle plus this angle equals to 180, right? So therefore we found angle x is equal to 65 and angle y will be the central angle. Therefore it will be 2 times the inscribed angle, which will be equal to 130 degrees, which will be equal to 130 degrees. That's the reason I did it both the methods, so guys you can see which you want to choose. All right, whichever way, that's the beauty in maths, all the time the answer will be the same. All right guys, now in this one, let's go ahead and see what can we do. So we see that this is the inscribed angle, so our angle x guys will be twice the inscribed angle, which is equal to 100 degrees, right? So we see that our angle x is equal to 100 degrees. Now as you can see guys, we know that OA and OB are the radii, and the radii have the same measure, right? Therefore we know that our angle y and angle z will be equal. Therefore our angle y and angle z will be equal to, let's see, will be equal to 180 minus 100, right? 180 minus 100 is 80, and 80 divided by 2 is equal to 40. So our angle y and angle z will be equal to 40 degrees. All right guys, will be equal to 40 degrees. Now I really hope you enjoyed this video guys. If you did, don't forget to hit on that like button, and I will see you next time. Have a nice day guys.